Welcome to our journey into sustainable engineering. In this video, we'll explore what sustainable engineering really means and why it's becoming increasingly important in today's world. Sustainable engineering is all about designing and operating systems in ways that use resources efficiently, minimize environmental impact, and support the well-being of both people and the planet. As we face challenges like climate change, resource depletion, and pollution, engineers are rethinking traditional approaches to create solutions that are not only effective but also responsible. Let's dive in and discover the core principles and practices that define this exciting field. Why do we need sustainable engineering? Our world is experiencing rapid population growth, urbanization, and industrialization. These trends put immense pressure on natural resources and ecosystems. Traditional engineering often focused on solving immediate problems without considering long-term consequences. Today, we recognize that our actions can have lasting impacts on the environment and society. Sustainable engineering aims to balance economic growth, environmental protection, and social well-being. By adopting sustainable practices, engineers help ensure that future generations inherit a healthy, thriving planet. A key concept in sustainable engineering is the triple bottom line. This framework encourages engineers to consider three pillars: people, planet, and profit. Instead of focusing solely on economic gains, sustainable engineering evaluates the social and environmental impacts of every decision. For example, when designing a new building, engineers might choose materials that are both cost-effective and environmentally friendly, while also ensuring the building is safe and comfortable for its occupants. This holistic approach leads to solutions that are truly sustainable. One of the foundational principles of sustainable engineering is resource efficiency. This means using materials, energy, and water in the most effective way possible. Engineers strive to reduce waste, recycle materials, and design products that require fewer resources throughout their life cycle. For instance, in manufacturing, engineers might redesign processes to use less energy or incorporate recycled materials. By prioritizing efficiency, we can lower costs, reduce environmental impact, and create more resilient systems. Life cycle thinking is another core principle in sustainable engineering. It involves considering the entire lifespan of a product or system, from raw material extraction to manufacturing, use, and eventual disposal. By evaluating every stage, engineers can identify opportunities to minimize negative impacts and maximize benefits. For example, choosing materials that are easy to recycle or designing products that last longer. Life cycle thinking helps engineers make informed decisions that support sustainability at every step. Pollution prevention is a proactive approach in sustainable engineering. Instead of dealing with pollution after it happens, engineers aim to prevent it at the source. This can involve using cleaner production methods, selecting non-toxic materials, or designing systems that generate less waste. For example, water treatment plants can be designed to minimize chemical use, or factories can implement closed-loop systems to reuse water. Preventing pollution not only protects the environment but also reduces costs and regulatory risks. Sustainable engineering emphasizes the use of renewable resources whenever possible. Renewable resources like solar and wind energy are naturally replenished and have a lower environmental impact compared to fossil fuels. Engineers are developing innovative ways to harness these resources for electricity, heating, and transportation. By shifting towards renewables, we can reduce greenhouse gas emissions, decrease reliance on finite resources, and create a more sustainable energy future. Social responsibility is at the heart of sustainable engineering. Engineers must consider how their projects affect communities and individuals. This means ensuring that solutions are safe, accessible, and equitable. For example, infrastructure projects should provide benefits to all segments of society, not just a select few. Engaging with stakeholders and listening to community concerns helps engineers design projects that support social well-being and foster trust. Systems thinking is a holistic approach that recognizes the interconnectedness of different components within an engineering project. Instead of focusing on individual parts, engineers look at how everything works together as a whole. This helps identify unintended consequences and optimize performance. For example, improving energy efficiency in a building might also enhance indoor air quality and reduce operating costs. Systems thinking leads to more robust and sustainable solutions. Continuous improvement is a mindset that drives sustainable engineering forward. Engineers are always seeking ways to enhance efficiency, reduce impacts, and adapt to new challenges. This might involve adopting new technologies, refining processes, or learning from past projects. By embracing continuous improvement, engineers ensure that sustainability remains a dynamic and evolving goal, rather than a fixed target. Green building design is a practical application of sustainable engineering principles. It involves creating structures that are energy efficient, use sustainable materials, and provide healthy environments for occupants. Features like natural lighting, efficient insulation, and renewable energy systems are common in green buildings. These designs not only reduce environmental impact but also lower operating costs and improve quality of life for residents. Sustainable transportation is another area where engineering makes a big difference. Engineers design public transit systems, electric vehicles, and bike-friendly infrastructure to reduce emissions and traffic congestion. By promoting alternatives to single-occupancy cars, sustainable transportation solutions help cities become cleaner, healthier, and more livable. These projects require careful planning and collaboration across multiple disciplines. Effective water management is crucial for sustainability. Engineers develop systems to conserve water, treat wastewater, and protect natural water sources. Techniques like rainwater harvesting, efficient irrigation, and advanced filtration help reduce water waste and ensure clean water for communities. Sustainable water management supports agriculture, industry, and public health, making it a vital practice in engineering. Engineers play a key role in developing renewable energy systems. Solar panels, wind turbines, and hydroelectric plants are all examples of sustainable technologies that generate clean power. These systems reduce dependence on fossil fuels and help combat climate change. Engineers must consider factors like site selection, efficiency, and integration with existing infrastructure to ensure successful implementation. Sustainable waste management involves reducing, reusing, and recycling materials to minimize landfill use. Engineers design systems for sorting, composting, and processing waste in environmentally friendly ways. Innovations like waste-to-energy plants and biodegradable packaging are helping to close the loop and create a circular economy. Effective waste management protects ecosystems and conserves valuable resources. Sustainable manufacturing focuses on producing goods with minimal environmental impact. Engineers optimize processes to use less energy and water, reduce emissions, and recycle byproducts. For example, factories might switch to renewable energy sources or redesign products for easier disassembly and recycling. Sustainable manufacturing not only benefits the environment, but can also improve efficiency and reduce costs for businesses. Choosing eco-friendly materials is a key practice in sustainable engineering. Engineers select materials that are renewable, recyclable, or have a low environmental footprint. Examples include bamboo, recycled steel, and biodegradable plastics. Using these materials helps reduce resource depletion and pollution, while also supporting innovation in product design and construction. Sustainable agriculture integrates engineering solutions to increase food production while protecting the environment. Techniques like precision irrigation, soil conservation, and integrated pest management help farmers use resources efficiently and reduce negative impacts. Engineers also develop equipment and systems that support organic farming and reduce reliance on chemical fertilizers and pesticides. Urban planning is essential for creating sustainable cities. Engineers and planners work together to design transportation networks, green spaces, and efficient utilities that support growing populations. Sustainable urban planning prioritizes walkability, public transit, and access to nature, making cities healthier and more enjoyable places to live. This practice requires collaboration across many fields and a long-term vision for community well-being. Environmental remediation involves cleaning up polluted sites and restoring ecosystems. Engineers use advanced technologies to remove contaminants from soil, water, and air. Projects might include treating industrial spills, rehabilitating wetlands, or reforesting degraded land. These efforts help repair environmental damage and create healthier habitats for people and wildlife. Climate adaptation is about preparing for the impacts of climate change. Engineers design infrastructure that can withstand extreme weather, rising sea levels, and other challenges. Examples include flood-resistant buildings, drought-tolerant landscaping, and resilient energy grids. By planning for the future, sustainable engineering helps communities stay safe and thrive in a changing climate. Sustainable supply chains ensure that products are sourced, manufactured, and delivered in environmentally and socially responsible ways. Engineers work to optimize logistics, reduce transportation emissions, and select suppliers who follow ethical practices. Transparency and traceability are key, allowing companies and consumers to make informed choices that support sustainability. Green chemistry is an approach that designs chemical products and processes to reduce or eliminate hazardous substances. Engineers and chemists collaborate to develop safer alternatives, minimize waste, and use renewable feedstocks. Green chemistry supports cleaner manufacturing and helps protect both human health and the environment. Co-design integrates environmental considerations into every stage of product development. Engineers assess the impacts of materials, manufacturing, use, and disposal, aiming to minimize harm and maximize benefits. Features like modular construction, energy efficiency, and recyclability are common in eco-designed products. This approach encourages creativity and leads to innovative, sustainable solutions. Biodiversity conservation is a vital aspect of sustainable engineering. Engineers design projects that protect habitats, support wildlife, and restore natural areas. Examples include creating wildlife corridors, planting native vegetation, and reducing light pollution. By prioritizing biodiversity, engineers help maintain healthy ecosystems that provide essential services to people and the planet. Sustainable packaging reduces waste and environmental impact. Engineers develop packaging solutions that use less material, are recyclable or compostable, and minimize harmful chemicals. Innovations like plant-based plastics and reusable containers are gaining popularity. Sustainable packaging not only benefits the environment but also meets consumer demand for greener products. Improving energy efficiency is a cornerstone of sustainable engineering. Engineers design systems and products that use less energy without sacrificing performance. Examples include LED lighting, high-efficiency appliances, and smart building controls. Energy efficiency reduces costs, lowers emissions, and helps conserve valuable resources for the future. Reducing carbon footprints is a major goal in sustainable engineering. Engineers calculate emissions from products and processes, then implement strategies to lower them. This might involve switching to renewable energy, improving efficiency, or offsetting emissions through reforestation. By tracking and reducing carbon footprints, engineers help fight climate change and promote sustainability. Sustainable mining aims to extract resources with minimal environmental and social impact. Engineers develop methods to reduce land disturbance, manage waste, and restore sites after mining is complete. Technologies like remote sensing and water recycling help make mining more responsible. Sustainable mining supports economic development while protecting ecosystems and communities. Smart grids are modern electricity networks that use digital technology to manage supply and demand efficiently. Engineers design smart grids to integrate renewable energy, reduce outages, and support electric vehicles. These systems help balance energy use, lower costs, and make the power grid more resilient to disruptions. Green infrastructure uses natural systems to manage water, reduce heat, and improve urban environments. Examples include green roofs, rain gardens, and permeable pavements. Engineers design these features to mimic natural processes, providing benefits like flood control, cleaner air, and enhanced biodiversity. Green infrastructure makes cities more sustainable and resilient. Sustainable fisheries use engineering solutions to protect marine ecosystems while supporting food production. Techniques include selective fishing gear, habitat restoration, and monitoring systems to prevent overfishing. Engineers also help design aquaculture systems that minimize pollution and resource use. These practices ensure healthy oceans and long-term food security. Sustainable forestry balances timber production with ecosystem health. Engineers develop harvesting methods that protect soil, water, and wildlife. Reforestation, selective logging, and certification programs help ensure forests remain productive and diverse. Sustainable forestry supports local economies and preserves vital natural resources for future generations. Sustainable tourism integrates engineering to minimize environmental impact and support local communities. Engineers design eco-friendly accommodations, efficient transportation, and waste management systems for tourist destinations. By promoting responsible travel, sustainable tourism helps preserve natural and cultural heritage while providing economic benefits. Sustainable healthcare applies engineering to create medical facilities and systems that minimize environmental impact. This includes energy-efficient hospitals, green building materials, and waste reduction strategies. Engineers also develop technologies for telemedicine and remote care, reducing the need for travel and resource use. Sustainable healthcare improves patient outcomes while protecting the planet. Disaster resilience is about designing systems that can withstand and recover from natural hazards. Engineers create buildings, infrastructure, and emergency plans that protect people and property during events like earthquakes, floods, and storms. Sustainable engineering ensures that recovery efforts are efficient and minimize further environmental damage. Sustainable education involves creating learning environments and curricula that promote environmental awareness and responsible engineering. Engineers help design green campuses, develop online learning tools, and integrate sustainability into technical training. By educating future generations, sustainable education ensures ongoing progress in the field. Sustainable finance supports engineering projects that deliver environmental and social benefits. Engineers collaborate with financial experts to assess risks, measure impacts, and secure funding for green initiatives. Sustainable finance encourages investment in renewable energy, clean technology, and resilient infrastructure, driving positive change across industries. Circular economy is a model where resources are reused, repaired, and recycled to minimize waste. Engineers design products and systems that support this approach, such as modular electronics and closed-loop manufacturing. The circular economy reduces resource extraction, lowers pollution, and creates new business opportunities. Digital technologies are transforming sustainable engineering. Tools like sensors, data analytics, and artificial intelligence help engineers monitor systems, optimize performance, and predict problems before they occur. Digitalization enables smarter decision-making and more efficient use of resources, accelerating progress toward sustainability goals. Engaging stakeholders is essential for successful sustainable engineering projects. Engineers collaborate with communities, governments, and businesses to understand needs and address concerns. Open communication and transparency build trust and lead to solutions that are widely supported and effective in the long term. Policy and regulation play a significant role in advancing sustainable engineering. Engineers work with policymakers to develop standards, incentives, and guidelines that promote sustainability. Compliance with regulations ensures that projects meet environmental and social goals while also encouraging innovation and best practices. Ethical engineering is about making decisions that are fair, honest, and respectful of all stakeholders. Sustainable engineers consider the broader impacts of their work, including potential risks and unintended consequences. Upholding ethical standards builds public trust and ensures that engineering solutions truly benefit society. Global collaboration is key to solving complex sustainability challenges. Engineers from around the world share knowledge, technologies, and best practices to address issues like climate change and resource scarcity. International partnerships accelerate progress and ensure that solutions are adaptable to different regions and cultures. As we look to the future, sustainable engineering will continue to evolve and expand. New technologies, changing regulations, and growing public awareness will shape the field in exciting ways. Engineers will play a central role in building a more sustainable world, finding creative solutions to complex problems and inspiring others to join the movement. By embracing the principles and practices we've discussed, we can create a brighter, more resilient future for everyone.